GU project and its risk management. Introduction. In the case of GU, the current problem that the project is facing is system failure due to unknown software that the system users, namely, students and instructors, have uploaded in their computers. Without a solution to the current problem, the system at GU may not achieve its expected function. Therefore, it is important to manage the current risks before the system is rolled out to full functionality. The paper will present my first course of action when responding to the current problem before revealing various measures that can be adopted to eliminate the issue. First course of action. The first course of action in the current problem is the identification of the software that is causing the system to fail. Without a clear understanding of the software, which is causing the system malfunction, it will be difficult to address current and future problems, which may be caused by similar software. The next step involves the analysis of the risk. In this case, the focus is on the kind of risks the software poses to the system. While the system failure is the immediate identifiable problem, other underlying vulnerabilities may be available in the system. Such issues should be identified to ensure that they are addressed adequately for optimal functionality of the system. After an analysis, it is important to undertake an evaluation of the level of risk to the whole system. Currently, while the apparent problem is system breakdown, the project is not aware of the reasons why the specific software is causing the system to fail. In addition, it is not yet known the level of impact or risk the software poses on the system. Consequently, a thorough evaluation of the above problem will ensure that the identified system vulnerabilities are addressed adequately. Plans and measures to be put in place and their impact on schedule. Once the risk has been analyzed and evaluated, it is important for the project team to make an undertaking on the next steps that may lead to the solution of the current problem. This process may involve mitigating future risks and putting in place contingency measures for any eventualities in the event that the mitigation measures fail. Software-related project failures can be caused by many factors, including a combination of software and hardware, as well as human factors. The measures will be addressing the current problem. Presently, the system is failing because of the unknown software used by students and instructors. Once the culprit software has been identified, the project team will determine whether it is causing the malfunction due to incompatibilities with the system or due to incongruity with the hardware. Once this issue has been identified, the project team can come up with solutions targeted at addressing the respective incompatibility. For instance, solutions targeted at the system software may relate to reprogramming the network for compatibility with the problematic software, while those targeting the hardware may require hardware changes. The measures will have an impact on the schedule of the project since it cannot continue unless the current system failure problem is addressed. The repair will not only lead to more hours used by the team, but also it will increase the cost of the project through the additional hours, and potentially, system changes that may be necessary for the problem to be addressed. The duration of the interruption to the schedule may vary from a few hours to several days. Hence, it is imperative for the project team to be prepared for any outcome. Human factors are also an important aspect in addressing a risk and in this case, should be considered. For instance, through training, the project team can be given the knowledge of the underlying factors that are causing system failure. Further, the team can be motivated through various approaches to guarantee more dedication to addressing the problem, thus reducing the impact on cost and schedule. Such knowledge will be crucial in solving the problem faster to reduce time wastage, which negatively influences the schedule. Preventive measures to reduce the risks. Once the above problem has been addressed, it will be important for the project team to put in place preventive measures to reduce future risks that may cause system failure. Preventive measures include mitigation and contingency planning strategies. In the first approach to risk, the project may focus on lessening the impact of the risks posed by system failure by making frequent upgrades related to the identified risks. These upgrades are important since they allow the system to be protected and its security enhanced based on vulnerabilities that are recognized through close monitoring of the system. Another important step can be expanding the capacity of the system to run multiple similar software components on the platform without any strain. This approach will be vital since it will reduce the likelihood of the system failing when it is simultaneously exposed to the same software by many people. Systems such as the one for the GU are becoming popular in the modern world. They are very crucial for the normal functioning of an organization. Such failures may be costly since they can lead to large losses to an organization. Consequently, insurance should be considered an important mitigative alternative that the organization can put in place to cushion itself from losses or any interruptions caused by system failure. The second preventive measure is through creating a contingency plan in the event that the mitigative measures fail. Contingency planning offers a substitute arrangement in the event that the main system fails. This option can be accomplished through creating a backup system, which can be used in case the main system malfunctions. The second mitigation approach can be through the establishment of a team, which will be dedicated to addressing system failures whenever they arise. This process may involve factoring in any costs that may arise when addressing system issues in the future. Conclusion. The process of identifying and solving the system failure addressed will be crucial in ensuring the current problem is addressed fully. Future-related risks will also be addressed. The risk identification involves analyzing the system to come up with the reasons for the failure before carrying out an evaluation to identify the scope of the risk. The process may be costly to the level of negatively affecting the schedule of the project. Once the problem has been solved, putting in place preventive and contingency plans will ensure that future risks are addressed.